We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
The topic is dimension analysis and similarities. The subject is fluid dynamics. This topic is divided into 2 parts. One is dimension analysis and another is similarities. Okay. Introduction. What is dimension? Any physical quantity is expressed in terms of dimension. Means a dimension is a measure by which physical quantity is expressed. For example, say the length is a dimension of variables as distance and displacement. Dimension may be 2 types: fundamental dimension and secondary dimension. Fundamental dimension. What is fundamental dimension? Fundamental dimension means all the fixed dimensions are called fundamental dimension. Means length, mass, time are 3 fixed dimensions. Secondary dimension. The secondary dimension is derived from fundamental dimension, that is called secondary dimension or derived quantity. For example, say velocity. Velocity is the dimension of velocity is derived from fundamental dimension. For example, say unit of velocity is what? Meter per second. So it is L by T, L T minus 1. Okay. This is the example of Buckingham pi theorem. Very most IMP question regarding the exam point of view. Before giving you a statement of Buckingham pi theorem and procedure, I will explain you the example of Buckingham pi theorem so you can easily understand the statement and procedure. Procedure I will explain you from this example. The example generally is what the efficiency N is dependent on density rho, dynamic viscosity mu, angular velocity omega, diameter d, discharge q. Express N is in terms of dimensionless parameter using Buckingham pi theorem. Now N is a dependent variable and another is an independent variable. The first step of Buckingham pi theorem is determine number of variables. So here we have seen that the total number of variables are 6. Okay, N is a dependent variable, another is an independent variable. So we can write N is equal to f of rho, mu, omega, d and q. This above equation is also we can write f of n rho mu w dq is equal to 0. Now next step number 2. Step number 2, determine total number of variables. Total number of variables is what? In previous I also repeated total number of variables is 6. Means step number 2 is to determine number of pi terms. Determine number of pi terms. Number of pi terms is determined by n minus m, where n is equal to total number of variables and m is a fundamental dimension. So we have already known that total number of variables is what? N is what? 6. And fundamental dimension is what? MLT. In previous slide I already explained you number of fundamental dimension is what? M is equal to 3. M, L and T. Fundamental dimension is what? Mass, length and time. So fundamental dimension M is equal to 3. So we can write N minus M is equal to 6 minus 3 is equal to 3. So number of pi terms is what? 3. Okay. Now this pi terms in step number 2, the pi terms is written in form of f of pi 1, pi 2, pi 3 is equal to 0. Now most important thing is determine the number of repeating variables. Number of repeating variables are find out by the 3 way. First step, select geometric property. Next step, select flow property, and next step is a fluid property. Geometric property means what? Length and diameter. Next, flow property is velocity and acceleration, and fluid property density, viscosity. You can take any one of these. Okay, so from this example, repeating variables, first one is the geometric property. Out of 6 variable, which one is the geometric property? Diameter. Next is the flow property. Out of 6 variables, we choose the flow property as omega, and then fluid property. root property, which select the row. So step number 4, select repeating variable and multiply remaining variable one by one. Multiply remaining variable one by one. So d omega rho, d omega rho, d omega rho is common in each and every pi terms. Next step is you have to multiply remaining terms, that is m, mu and q. So d raised to a1, omega raised to b1, rho raised to c1. Similarly d raised to a2, omega raised to b2, rho raised to c2. Similarly d raised to a3, omega raised to b3, rho raised to c3. So these are the 3 steps of pi 1, pi 2, pi 3. First pi 1 terms, that is d omega rho a3 b3 c3, that is d raised to a3, omega raised to b3, rho raised to c3 into n. Now put the value of pi 1, that is m0 l0 t0. Diameter, that is the geometric property, the unit of diameter is meter. M0 l1 t0 raised to a1. Similarly m0 l0 t minus 1, unit of omega radian per second. Rho density kg per meter cube. M l minus 3 t0 raised to c1, m0 l0 t0, unit of efficiency. Now equating the power of both the sides of the equation, that is power of m, power of l, power of t. So we can find c1 is equal to 0, a1 is equal to 0, b1 is equal to 0. Substitute the value of a1, b1, c1 in the equation of pi 1. So we can find pi 1 is equal to n. Okay, second pi 1 terms, pi 2. Similarly d raised to a2, omega raised to b2, rho raised to c2, mu. Pi 2 m0 l0 t0, unit diameter meter, omega radian per second, and rho kg per meter cube. So diameter meter, that is m0 l t0, omega radian per second, that is m0 l0 t minus 1, and density, that is m l minus 3 raised to c2. Mu, that is the dynamic viscosity, unit is m l minus 1 t minus 1. Similarly equating the power of both the sides of the equation. So the power of m is what? c2 plus 1 is equal to 0. Power of l, a2 is equal to minus 2. Power of t, b2 is equal to minus 1. Substitute the value of a2, b2, c2 in equation of pi 2. Pi 2 terms, pi 2 is equal to t raised to minus 2, omega raised to minus 1, rho raised to minus 1, mu. So pi 2 is equal to mu divided by d square omega rho. So pi 2 terms is equal to mu divided by d square omega rho. Third pi terms is find out same thing, procedure is repeating. Pi 3 m0 l0 t0, put the dimension of d omega rho. Only one change is discharge q, meter cube per second. Discharge, the unit of discharge is meter cube per second. m0 l3 t minus 1. Equating the power of both the side, you have to determine a3, b3 and ct. Put the value in this equation, so we will get the final value pi 3. Substitute the value of pi 1, pi 2, pi 3 in equation 2. F1 n mu divided by d square omega rho, q divided by dq omega is equal to 0. So we will get final equation is n is equal to, we will get the final value is n is equal to 5 into mu divided by d square omega rho, q divided by dq omega. Next is similitudes. Okay. Geometric similarity. Geometric similarity is said to exist between model and prototype if the ratio of all corresponding linear dimensions in model and prototype are equal. It means all the dimensions, the ratio of all the dimensions of model and prototype are equal. That is called geometric similarity. And we have seen some notation like L suffix m, that is the length of model, diameter of model, volume of model, breadth of model, area of model. Similarly, different types of notation for prototypes are given. So it is this is the mathematical form of geometric similarity, in which length of model and prototype are equal in each and every aspect. Next is the kinematic similarity. Kinematic similarity exists between model and prototype if the ratio of velocity and acceleration as corresponding point in model and prototype are equal. It means motion between model and prototype are equal. That is called kinematic similarity. These are the different notations of velocity and acceleration of model and prototype. And this is the mathematical form of definition. Then the dynamic similarity. Dynamic similarity exists between model and prototype if the force ratio forces of corresponding points are equal. It means forces between model and prototype are similar. That is called dynamic similarity. Dynamic similarity, that is the different notations of forces of model and prototype, and this is the mathematical form of dynamic similarities. Dimensionless number. Dimensionless number are the number which are obtained by dividing inertia force by viscous force, gravitational force, pressure force, surface tension force, and elastic force. There are the different types of dimensionless number, that is a Reynolds number, Coulomb number, Euler's number, Weber's numbers, and Mach numbers. Reynolds number, it is defined as the ratio of inertia force to viscous force. It is denoted by Re. The equation of Reynolds number is ρ L by μ. The significance is very important regarding exam point of view. If you read, it is easily explained. Example of this Reynolds number are flow through the pipe, motion of submarine completely in closed pipe. In exam, they have asked the question, explain different types of dimensionless number and explain its significance. Flood number. It is defined as the square root of ratio of the inertia force and gravitational force. It is denoted by F suffix R. Next is a Weber number. It is defined as the square root of ratio of inertia force to surface tension force. It is denoted by W suffix A. This one is the significance. And Mach number. It is defined as the ratio of square root of ratio of inertia force to elastic force. It is denoted by M. Weber's number. It is defined as the square root of ratio of inertia force to surface tension force. It is denoted by W suffix A. Then Euler's number, it is defined as the square root of ratio of inertia force to pressure force. It is denoted as E.